3D printers could make ultra-fast internet cheaper. Researchers have found another cutting-edge use for 3D printing, namely creating optical silica preforms to make fibers, simplifying their production and substantially reducing manufacturing costs. Optical fibers, of course, have many uses including, but far from limited to, the very infrastructure of ultra-fast internet. So any savings that could be brought in on the manufacturing side will help with the rollout of speedy connections, and hopefully the pricing of them too. When it comes to the consumer, 3D printers can build a house in 2 days. Best printer for Mac in 2019. These are the best 3D printers of 2019. This particular project is a collaboration between research teams drawn from multiple universities across the globe, including the University of Technology in Sydney, the University of New South Wales, and both Harbin Engineering University and Yanshan University in China. As the engineer reports, John Canning, who heads up the Sydney-based team, commented, "Making silica optical fiber involves the labor-intensive process of spinning tubes on a lathe, which requires the fiber's core or cores to be precisely centered. With additive manufacturing 3D printing, there is no need for the fiber geometry to be centered. This removes one of the greatest limitations in fiber design and greatly reduces the cost of fiber manufacturing. Let there be direct light." The actual 3D printing process used is known as direct light projection and is a highly innovative and demanding technique, with the printing of glass requiring a temperature in excess of 1900 degrees Celsius. This process is achieved using a commercially available printer, although the technique still hasn't been perfected. The initial runs produced fibers which suffered from high light loss characteristics, but the root causes of these problems have been pinned down, and the researchers are successfully figuring out ways of working around these issues by all accounts. As Canning notes, the process could be applied to a whole raft of different optical components, potentially replacing conventional lathe-based production of silica optical fibers. Along with the aforementioned production time savings, as well as much better cost efficiency, the new method would also be safer and require less expense on the training front. Further applications could include ushering in more widespread usage of fiber optic sensors, which are superior to electronic sensors in multiple ways including their longevity and general durability, and of course the fact that they do not require power at the site.